Presentation, I'm going to be talking about the application of finite automata in search engine. To start off with this, we need to know what a finite automata is. So finite automata is nothing but a simple machine which has a limited memory and is used to recognize patterns and used to characterize regular language. What does this even mean? Let's first take a look at this in a real life perspective. For instance, let's take a vending machine which gives out two different snacks, either chips or soda. But how will the machine know when to give a person chips and when to give a person soda? So each object in a vending machine will have a specific code. So for instance, chips has a code 1011 and imagine soda has a code 111. So when 111 is entered, the machine will know that the person is asking for soda. And when 011 is entered, the machine knows that the person is asking for chips. So finite automata is the machine which recognizes the pattern or the string and will help the machine to give out the specific object. So after this, now let's take a look at the Now we're going to look at the tuples of a finite automata, which consists of 5 symbols. The first one is Q. Q indicates the set of states. Summation indicates the set of input symbols. I'll explain each of this in detail when I take an example. Q naught indicates the initial state of the finite automata. F indicates the final state, and delta indicates the transition function. Transition function is nothing but when a particular input symbol is applied onto a state, it will tell you where the next transition should be. Okay, now let's take an example where the alphabet set is 0 and 1 and the string should be accepted only if there is 3 consecutive zeros. This indicates that we need to accept any string which has a substring 3 zeros. So for this, first we know that we need 3 different states for the 3 zeros to be verified plus one final state. So we need 4 different states. Q0, Q1, Q2 and QF. But QF was a final state, so we have to indicate that with double circle. Okay, so now let's get started. So when we have 0, we have to go to the next state. And when we have another 0, we have to go to the next state. And when we have another 0, we go to the final state. So this is the NFA for the given question. So when 3 zeros are applied, each 0 will transition to the next state and reach the final state. But what if they ask for a DFA? A DFA is when all the inputs symbols should be there in all transitions. So the first one be when Q0 in the Q0 position, if 1 is given. So for instance, the string is 1000. What should the 1 do? When the 1 is applied, we should do self transition just so that it doesn't get affected. What about when it comes in the second position? Like this. So when zeros there, we go from Q1, Q0 to Q1. And at Q1, what should happen when 1 appears? When 1 appears, it should go back to Q0. So how? Let's see if the string accepts. If this string gets accepted by this. So first 0, so Q0 to Q1, then 1, so it goes back to Q0, and then 3 zeros, so it will be accepted. So what if I get a string which is 0 0 1 0 0 0? So in this case, it will move to Q2 state, but when 1 appears now, we have to still go back to the Q0 so that the string can get accepted. But what about the final state when 1 appears? It doesn't matter. We have already reached our goal, which is three zeros. And then how many ever one can appear. So this can be self transition 0 comma 1. So how many zeros or how many ones can appear, that doesn't matter to us when we have already reached our goal. So this is the DFA for the particular diagram. So okay, now let's look at the transition table and also talk about the tuples. So in the transition table, first we need to know the input symbols, which is 0 and 1. So these are our set of input symbols. So and the initial state was Q naught and our final state was QF. And also when we draw the transition table, we will know the transition function also. Okay, so now let's start this off. So when Q naught appears, when we're in the Q naught state and when 0 appears, we know that we need to go to Q1. But when Q naught appears, when we are in Q naught and 1 appears, we need to remain at Q naught. Similarly, now we have to take Q1. Okay, so when Q1 is here and 0 is applied, then we have to go to the next state, or we have to go, when 1 appears, we have to go back to Q naught. Now let's take Q2. In Q2, when 0 appears, we have to go to QF, which is the final state. But when 1 appears, we need to go back to Q naught. Similarly, now let's take for the final state. In final state, when 0 or 1 appears, we remain in that state itself. Since we added self transition, so it will just be QF. So these are the transition functions where we have went from when Q naught and 0 is applied, we go to Q. So this is the transition. So this is how you show transition function, and this is the transition table for the given example. Now let's get into the application of a search engine. So what is a search engine in the first place? So Google, Chrome, Opera, Brave are all search engines, and we have all noticed that when we enter a certain word, we will get many suggestions, many set of words which we are looking for actually. So how does this even work? This mechanism is helped by the finite automata. You can clearly see here when I went and searched theory in my search bar, it has already given me a suggestion saying theory of computation. How does this work? So search engine has three main steps. It first does something called crawling. Crawling is when the web crawlers go through the internet for content and like text, image, and will give the crawled content, basically ones which are very eligible, which are more close to whatever you're typing. After that, it does indexing. It analyzes and processes the crawled information and puts index on them. And then it will rank. So, which is more relevant to you? Like if you have searched some topics related to TOC and you type theory, then you're most likely to get theory of computation. So, it depends on your previous search history. It depends upon whether you have already searched that word before and all that. So, based upon that, it will rank. It will give you the most suggested as the first word, then second suggested, like so. So, these are the three main activities that happen in search engine. Now let's have an in-depth look upon how a search engine works with the DFA algorithm. Now look at the screen and my example. Now when I search null in my search bar, it's giving me multiple suggestions. Okay, so all these suggestions include this word null in it. So obviously the suggestions are a bunch of strings which the search engine already contains, and those strings are all validated by a DFA, and based upon that they appear. So in this example, the strings will be like this, appear like this. So null production, So this will get passed on to my DFA, and if null is present in the string, then this will appear onto my search engine request. Okay, so how does null production come first, then null in minimization of DFA? So each of them appear depending upon recently searched or the one that's closest, likewise. So now let's perform this DFA onto my example. Okay, the bunch of strings which are available. So now that I have to check for the word null in it. So in order to create a DFA for this, first we start and we only move on to the next state when n is applied, and we move on to the next state when u is applied, and l and another l. In this example, I'm only showing it for the small letters in the alphabet. You can also do this similarly for all the letters in the alphabet. You just have to show it in your DFA, like capital and all that. So now that I'm taking this, when only n is showing, we go to Q1 state. But what if it's not n? If it was any other letters in the alphabet, my language belongs to any letters in the alphabets. So in that case, if it's any other letters, I have to write this as A to Z minus n, since this indicates that any letters other than n. Okay, now what about when a different letter appears other than u as your second letter? When what if the word is na? Then it should not go to the Q2 state. It should remain in the Q1 or Q0. It should actually go back to Q0 because NA is not valid. It's not going to give you null. So we have to go back to Q0 in search of null again. So we go back to Q0 when my alphabet set is not U. But there's another thing we have to notice here. Since n is the starting letter of the string, it could come n number of times. It could be this also. This is also a valid string for us. So n can come any number of times. So in the Q1 state, we have to self transition for n. So when we do that, we have to exclude the n here. Since we are creating a DFA, the input symbol cannot appear for more than once in a particular transition state. So yeah, now let's move on to the Q2. What if L doesn't appear? Then obviously we have to restart again, right? So that means we have to go back to Q0. But now, when will we ever go back to Q0? When my state is anything other than L, right? And what if N appears? When N appears, I don't actually have to go back to my Q0. Since I've given a self transition here for N, I could just bring the N back. I could just bring this back to Q1 and put N. So what this indicates that I can just bring it back to Q1 and then null ULL will happen. Okay. So for instance, till now we will have an example string. What if I insert N O N U L L? So when N is given, it'll go to Q1 state, and when O is given, since it is not the correct letter, it will go back to Q0. And then when n occurs again, it will come to Q1, then U, then L, then final state is reached. So this will be verified. So what about the next one? What if the second L doesn't appear? Then we have to again go back to the Q0 state. In this condition, we have to also write minus L, since if L transition is there, you go to the final state. But if when any other letter other than L appears, then you should go back to Q0. And here also you have to mention minus N, since we have already created a transition for N to go back to Q1. So what if n appears here in Q3? Then we have to do the same thing again and bring it to Q1 instead of Q0. Since we can just put n here, then it'll just continue the transition. So here also you have to give a minus n. So now final we have to give um, a self transition for A to Z. So it doesn't matter what n number of alphabets can come, any number of alphabets can come, that doesn't matter because we're only checking for the substring of null. So this is how all the search engines perform and check for the null value in each of the string that it contains in its search engine, and it will check whether whatever you typed appears onto the string, and if it appears onto the string, then it will automatically appear onto the search page, and that's how you get your suggested messages.